Sadaf A. Sadiq Garu, Siddiqui Garu. Sir is working as a marketing manager for IoT, quantum computing, and automotive electronics with Keysight Technologies India. He works very closely with academic and government research institutes as well as private organizations working in some of these cutting edge technologies and application areas. He has got more than 16 years of work experience in test and measurement, embedded and software industry domain. Prior to this, Sadaf Garu has worked in different roles like technical application engineer, global education program manager, focusing on some of the key product lines and industry segments. He has been active voice of customer, working closely with design and validation team for solution enhancements. He has delivered various talks in industry forums and panel discussions. He is an active contributor in Keysight Technical Case Studies program and Electronics and Telecom Media for Technology and T&M articles. Sadaf Garu earned his bachelor's degree in electronics engineering from AMU, India. He received a postgraduate diploma in business management marketing from Symbiosis Institute, Pune. Today's session, sir is going to talk about the machine learning algorithms for wireless communications. We welcome you, sir. Over to you.
Thank you so much for the kind introduction. So can you just confirm once again if you can hear me okay?
Yes, sir, we can hear you.
Okay, perfect. So good afternoon, or rather I should say good evening to all of you. So first and foremost, thanks for giving me this opportunity to be a part of this great event. Now, before I start off with my formal session, I was just listening to my previous peers presentation and for the last 5 or 10 minutes, and I would say the theme of this particular program, it's very exciting, it's very interesting. Like we are talking about wireless communication, focusing more on 5G and 6G. And as we were listening to the previous presentation, it was more focused around the simulation or the design aspects of 5G components. So the overall objective for me also in today's session is like, it would not be just limited to, let's say, a machine learning component, but then as I believe most of you would be knowing Keysight Technologies as a company. So I'll be anyways introducing the company in brief in few seconds, but I would also be adding few additional dimensions to my session talking about, I would say, the overall design simulation, uh, validation aspects to this particular industry, and also bringing in some new elements. So with this, let me share my screen. So ma'am, can you just confirm if you can see the presentation now?
Sir, not yet, sir.
Yes, sir. Yes, sir.
Yes, sir. Okay. Yes, sir, it's visible.
It's visible?
Yes, sir, it's visible.
Okay, perfect. Yeah, thanks
Okay.
for
Okay,
confirming.
Okay, sir, thank you.
Okay, so from an agenda point, like we will be spending another, I would say, 70 to 80 minutes on this particular session. And as I mentioned, like I would not just be limiting to one particular aspect. And here again, like my whole objective is not to talk or not to take all of you too much into depth, because we have a lot of faculty members also, I believe, sitting into this particular forum. And from a student's perspective, I think teachers or the faculty members, they are the best resources to cover all these things technically. So we from industry, we cannot definitely match all the technical expertise which the faculty members are bringing. But definitely, I would like to add in some value in terms of bringing some aspects which can help you on the practical side and also representing an industry. I would like to add uh, what all work is being going on into this particular topic within the industry. What are the various avenues where you can look into from a research perspective? And then also, let's say if you have to choose a topic maybe for your future studies or maybe projects. So some of these uh, topics or applications which I'll be covering. So these can give you idea in uh, which things can be taken forward, because uh, while you might be hearing from yesterday, and also as you might be seeing from different pieces of news, or you might be reading different IEEE papers or any other resources available on the internet. So 5G, very simple thing, it's not just about the smartphones or rather phones. 5G and then the futuristic 6G, it's bringing a very different perspective. It's bringing a very whole new dimension wherein like we will be taking this particular technology into various other applications, and I'll be covering few applications also to introduce like how 5G it's being leveraged over that industry, and then what are the different components, then the challenges, and then the sub applications which can be used over there. So from a takeaways perspective, as I mentioned, like definitely I want to add in some flavor of the design in simulation also, because still in India, if we see a lot of work it's happening on this particular front, and coming from Keysight technologies, wherein we are also focusing a lot on the design and simulation side via our tools. And then we are also talking about various measurements, be it on the physical layer or the protocol layer. We are talking about things like deep learning, artificial intelligence, machine learning, software automation via our software pieces. So I'll be leaving you with some of these buzzwords to later on think over, and then maybe choose some of these as the research topics. Uh, on the 5G and 6G side, like I'll be just giving a few basics or maybe a primer, whatever you can say. And some of these things might be repetitive, but then it always helps to set the context of the overall session. And then also it will be very easy to link the overall material with some of these basics. And in particular, as I mentioned, like 5G, it's not just about smartphones. So we are also talking about a lot of use cases. So for today's session, I have picked up one of the use case, which is from automotive industry called as CV2X, wherein we will be seeing the role of this particular technology in particular on the automotive side, which is again very interesting aspect. And then in the end, like I'll be concluding with a brief overview on the 6G, and then what are some of the new things which are coming up on 6G, and more on, I would say, the measurement side. Because uh, although we may say that we are talking a lot about artificial intelligence and machine learning in 5G, but it's still uh, I would say that it's limited in nature, and we would be seeing a very wholesome usage of AI and ML in the 6G. So then I'll be covering some portion of that on 6G side also. Now, apart from me, I have also included some recorded portions or videos, you can say, uh, wherein I would like to demonstrate some portion of the tools from a design and simulation perspective, which is being done covered by one of my colleagues. And then also in the 6G side, I'll be leveraging some of the recorded portion from one of our uh, senior speakers who delivered a very interesting talk on 6G, adding a new flavor of measurement. So it will not be a monotonous session covered just by me, but we'll be having few other speakers and few recorded sessions also. And feel free to add in any questions in the chat window. So we will take some break in between to respond to those questions. And if I'm not able to answer to all the queries, so I'll be leaving my email ID afterwards, and then you can reach out to me anytime with that ID. Okay, so who are we? And this is a very quick introduction for people who don't know Keysight Technologies as a company. So basically, we are around 80 to 85 years old brand, and we are coming from the strong legacy of HP. So the very first brand name of this particular company was Hewlett Packard or HP, which started off with the test and measurement product in 1939. And then it further diversified into various other product lines like servers and computers and laptops, which is still the brand which they are retaining. So HP got splitted into two companies in 1999, like which was HP and Agilent Technologies. So the second brand name for this test and measurement portion was Agilent Technologies, and which again diversified into life sciences and chemical instruments. And 6 years back, Agilent got splitted into further two sub companies, which is Keysight Technologies and Agilent. And the original test and measurement portion, it's being rebranded, or the name of the new company, it's Keysight Technologies. So as a brand name, it's new, I would say, but then from a legacy perspective, from our measurement perspective, from the presence perspective, we are having a very strong background. And this is a US based organization. We are having our impression in a lot of countries, as you can see over here, around 150 locations. And we have roughly around 13,000 employees worldwide. We are having our own dedicated fab and ASIC design center, with the help of which we are able to design our own ICs and MMICs, and we are able to put those into our innovative solutions. We have a very wide portfolio of solutions catering to various stages, be it design, validation, manufacturing stage, cutting across various technologies also. In India, we do have our sales and marketing office, as well as we have our R&D also in Gurgaon, wherein we have roughly around 800 to 900 people. And we are doing a lot of this software work as well as a lot of hardware work in India. Okay, now from a technology perspective, see, if we talk about 5G as a technology, or maybe any of the current technologies, as you might be able to connect yourself with some of the icons displayed over here that we are talking about, like micro satellites or nano satellites. Then we are talking about artificial intelligence. We are talking about autonomous driving. We are talking about augmented reality or virtual reality. We are talking about wearables. We are talking about data centers. So one common thing which you can correlate with any of these technologies is we are talking about connectivity first and foremost in all these technologies. And the word connectivity means that if you see any of these technologies, for example, like at this point of time, all of us, we just want to be connected anytime, anywhere or everywhere. Which again means like we need a very strong, robust network first and foremost. Then the second thing is, as any of these technologies, if you see, so these are always capturing the data, analyzing the data, and then at the back end, all this data, it's being reused or repurposed to make it more meaningful. But end of the day, if we see the overall complications over here, so we are talking about very smaller components first and foremost. We are talking about very high level of integration, which is increasing a lot of complexity in both design side as well as test side. And any of these technologies, if you see, like the window, it's very short, meaning all these technologies are continuously evolving. So nothing is fixed, nothing is freezed. Every few months or few years, we see next version or a revision of that particular standard. And then we have to continuously see that all these technologies or the products, these are backward compatible as well as forward compatible also, which means we have to adhere to a lot of changes in the hardware as well as a lot of changes in the software side also. The second big aspect is, which is again correlated to the topic on the machine learning or the artificial intelligence side. In any of these technologies, we are talking a lot about the data. Uh, Now, you may hear a lot of different words like big data or digital designs or those sort of things. But end of the day, we are talking about massive tons of data which is being produced every day. Now, for the designers or for the engineers, the big task is how to really make use of that data, because data is something which can be very meaningful to you if we can use it to the fullest and in the optimized manner. And for that only, we are talking about a lot of new algorithms, which I believe as a student, you will be definitely learning while you will be going through all these courses. And once you transition into industry also, then there are a whole bunch of companies which are actually working just on the data part or on the software part. Because while the front end can be limited, but then at the back end, the data is something which cannot be defined or limited with the boundaries. So that is why we need to really focus a lot into all the data which is being generated and make it more meaningful. Coming to the 5G side very quickly, and I won't spend a lot of time because I believe most of you are already aware with all these terms and terminologies. So in 5G, the key vision or the target when it was introduced a couple of years back was three main pillars, which was called as uh, ultra reliable low latency. Then we were talking about massive machine communication, and we were talking about enhanced mobile broadband. And if you see this particular spider diagram, each of these pillars, they have their own advantages or features. Like if we are talking about low latency, so basically we are targeting some very critical control applications, which requires strong security, which requires ultra high reliability, which requires ultra low latency. Then we are talking about enhanced mobile broadband, wherein we are trying to cover extreme capacity. We are talking about extreme data rates, and we are talking about awareness also. The third side is the massive Internet of Things, wherein we are talking about energy, and then we are also trying to solve the complexity, and we are trying to also look into the density aspect of this particular thing. Okay, so I talked about. Yeah, just 1 second. I'm facing some technical glitch. 1 second. Yeah, sorry. Okay, so as we talked about these three things like a massive machine communication, low latency, and enhanced mobile broadband. So all these three use cases, they have their very different frequency needs. And if you look into the bottom layer, which is the frequency band, uh, so you can see all these three different use cases, they are operational or they can work into different frequency bands. Like if we look typically into the massive machine side, so we are talking about low level of bandwidth, meaning low frequency, and that is when we can say that it can easily be classified within 3 gigahertz range. Likewise, if we are talking about ultra reliable low latency, which is like a 1 millisecond latency, what we are targeting with the help of this technology. So then we can cover it up to 6 gigahertz or maybe 7.1 gigahertz and all. And if we are looking into the enhanced mobile broadband, so here we are really looking into very high capacity, which means high bandwidth and high frequency. And for these things also, if we just move into the next slide. Yeah, this one, for example. So in 5G, as you might be aware, we are talking about two bands in particular, which is called as frequency range 1 or the FR1. And then we are talking about the second band, which is FR2 or the frequency range 2. Now, FR1 is more of a 5G new radio band, which earlier it was decided from up to 6 gigahertz, but now further expanded to 7.12 gigahertz. And FR2 band, which is more on the millimeter wave side. Here we are talking about millimeter wave frequencies. So for example, we are covering like from 23, 24 gigahertz up to like 50, 55 gigahertz and all. Right now, most of the work which is happening, it's still limited to FR1 band, which is a sub 6 gigahertz or 7 gigahertz band. But down the line, when we will be seeing more of use cases applications, so then we will see the work transitioning towards the millimeter wave bands also. Some of the use cases or applications. Now 5G, as I mentioned earlier, it's not just a smartphone technology, but it is trying to benefit both consumers as well as industry. And that is when you might be hearing a lot of applications or use cases like IoT, smart cities, smart parking projects, healthcare industry, its usage in industry 4.0, its usage in autonomous industry and various other industries also. From a network perspective, now in 5G, basically there are two types of networks which are being defined. One is called as the non-standalone network, which is you can consider it as an evolution from 4G to 5G, meaning like all the uh, backend or all the 4G components will be leveraged. So 4G setup will be used to establish the call or the data, and then it will be directed towards the 5G NR for the data session. So here we are leveraging the 4G infrastructure for 5G, you can say, which is called as the NSA or the non-standalone mode. The second mode, wherein the end-to-end setup it's being done, it's called as the standalone mode or the SA mode, wherein the call setup or the data session, it's being used over the 5G NR RAN or the radio access network, and then the core network. So this means like we are completely overhauling the entire infrastructure in this particular network. So just two things to remember from a network side. There are two networks. One is the NSA or the non-standalone. Second one is the standalone network. From a release perspective, now this may vary from country to country, but then this is more on, I would say, how the technology is evolving. So the basic committee or the organization which is responsible for this particular application, it's called as 3GPP. And this is responsible for developing the standard for 5G. Now 5G NR or 5G as a technology, as you all know, that it is continuously evolving. And from time to time, we are seeing new releases. So for example, like a couple of months back, we were hearing about release 14 and 15, and now there are talks going on for release 16 and 17. So the whole idea is different new use cases, different applications, different features and functionalities are being introduced with each of these releases. And that is when we will be seeing various other use cases or applications which will be leveraging 5G as a technology. Now, this particular slide, although this is a dense slide, but this is just to give you a perspective on what all features are being introduced in which all releases. So for example, in release 15, which is like more of established release now. So we've talked about a couple of things like the non-standalone and standalone network, then massive machine communication or the Internet of Things were a part of that. V2X was introduced in release 15. And then few other network related dimensions, which we will be covering later, like slicing and then service based architecture. All these things were introduced. Likewise, as the technology evolved to release 16 and 17, So various other functionalities were being introduced either on the efficiency side or on the network side or on the antenna architecture side, so that it can be introduced to other applications also. Okay, now one very interesting question, that how Keysight is involved or why companies like Keysight are involved with this particular application. So if you talk about any of these technologies and 5G in particular, 5G is something which is like introducing a lot of new things. So be it on the, I would say, modulation side, or be it on the frequency side, be it on the component side, be it on the network architecture side, be it on the base station side. So the whole infrastructure, it's being renewed, which requires a design and development of various components, subsystems and systems. And while we are talking about designing of these electronics, so definitely we need to test it and we need to validate it before launching into the market. So that is when companies like Keysight play a crucial role. Because with the help of various tools, what we offer, you can really look into different aspects. So starting with the design and simulation part, then moving towards the development or the integration of these parts, and then finally setting it up. So meaning like when we have set up, or when companies, they have set up the base stations, the network. So how will the actual devices perform in the real environment? So in order to characterize all these things, definitely companies rely on various tools. And that is when, if you see, starting from the chipset companies like Qualcomm or ST Micro or Samsung, for example, then we have players like Ericsson or maybe Nokia, who are working on the network side, coming up with different base stations or the network architecture. Then there will be operators also like Jio or Airtel or Vodafone, for example. So the entire ecosystem is working very hard to come up with new infrastructure, new components, and they are using all these different test and measurement products to look into various things. Now, while we work upon these technologies, so the different elements which are required to be tested. So the product, uh, it's being defined as UE over here, or the user equipment. Now this can be your smartphone, it can be a vehicle also, it can be a sensor, a modem, or anything. So this is being called as UE. The base station, this is called as the G node B over here, which is responsible for transmitting and receiving the communication. Then the second picture, if you see, so the channel, so this is basically the link between the user equipment and then the base station or the G node B. And then the whole core network, which is like the overall layer of the entire setup. So these are four things on which different companies are working, on which different research is going on. And then these are the four things which are required to be tested before introducing any of these things. So I'll start off very quickly with the design and simulation perspective, because this is something which we are seeing a lot in the academia as well as industry. Now, the very first stage of any technology, so we can say that a lot of research, it always starts with academia. And the research, it always starts with the design and simulation phase, meaning like, let's say if we have to design a network, or if we have to design a component, or if we have to design a system. So it always starts with all the design and simulation part over here. And typically considering the complexity of 5G or 6G as a technology, so which requires various new things, new waveforms, new modulation schemes. And then also while we deploy these things, so we will be talking about tons of data which is required to be analyzed and all. And all these things, like as these are fast evolving, complicated in nature, so the design in simulation tools also over here, the software rather, I can say. So these needs to be very robust, which can really configure your designs very easily, test your designs very easily, optimize it, and then simulate it as per the real world conditions. So I want to spend a lot of time because this is not a scope for today's presentation, but just to quickly introduce here, if some of you might be using in your labs or not, maybe in the future, you might come across some of these tools, which are very established tools within the industry. So these are called as Pathwave Design and Simulation Software from Keysight. And we have a whole bunch of different platforms. So platforms like ADS, for example, which is being used for antenna design system. Then we have something called as System View. Then we have something called as EM Pro, etc. So the thing is, if you see these categories, like we may require some tools for testing RF and microwave technologies. We may require some for high speed digital. So that is when like we have categorized it under these different buckets. Typically, if we talk about 5G or any of the wireless communication technology, now here again, one very key thing is if you especially see the FR2 technology or the millimeter wave technology, we are talking about the microwave frequencies, like frequencies beyond 25 or 28 plus gigahertz, and we are talking about very broad modulation bandwidth, high frequencies, etc. So these really complicates the overall design, and we really have to look into the various losses, various interferences, etc. So some of these are different test challenges or different design challenges which have to be taken care of. And as I mentioned, a lot of research work is happening in various institutes within India to really either design a new antenna, something like a MIMO antenna, or maybe a new network or a new power amplifier, for example, which are really the core components of this particular technology. Okay, so I'll just take a pause over here, and if you have any questions, you can submit it in the chat window. Meanwhile, I'm just going to uh, present a short demo with the help of one video which was being presented by one of my colleagues. Now, this is more of talking about some of the real world examples in wireless communication, uh, which is being handled by some of these tools. And the tools what I have listed over here. So you might want to go through some of these demo videos. And in case if there are further questions, so I'll be able to take that afterwards. So just give me a moment while I'll share the video from my side. So I'll be playing a Keysight video from the YouTube. So ma'am, can you just confirm if you are able to hear the sound?
No, sir.
Okay, 1 minute.
First, I want to briefly comment on the RF and microwave industry trend that relates to the explosive need for EM simulation by RF and microwave circuit designers. Then I will introduce to you RF Pro in ADS, followed by 5 short demos as you see here. So let's get started. The industry trend in RF and microwave design are driven by consumer demand for.
Hello.
Yes, sir. Yes, sir. Now it is audible.
more functionality in smaller size and at increasingly higher application frequency bands with broadband modulated RF signals. And this translates into denser and denser integration of complex RFICs, mimics, passives, filters, packages, and antennas at higher frequencies. This also means that the design of these RF and microwave components and integrated modules are becoming more challenging because circuit simulation must certainly be combined with 3D EM simulation to account for parasitic and coupling effects of these complex multi-technology integrated structures. As you see here, we're now witnessing 5G technology, which is operating in the 28 gigahertz millimeter wave band. Now, other upcoming high volume and high revenue applications are in the automotive radars and wireless networking application that work at much higher frequencies. So you can see as a result of this, the work for RF and microwave circuit designers are definitely not getting any easier. Now, during the past years, our customers, the circuit designers, have been telling us on their needs when using 3D EM simulators. They share difficulties with us when they perform EM circuit co-simulation that is so crucial for successfully completing their design of MMIC, RF modules, and RF PCBs. And based on their needs and feedback, we have created RF Pro, a great EM circuit co-simulation environment that is tightly integrated in ADS. And it enables easy access to EM analysis by RF and microwave circuit designers whenever they need it during design. So RF Pro addresses 3 common requests from designers. 1, no layout modification. You don't change your layout. No cookie cutting when you do EM analysis. 2, automatic and correct setup of EM analysis to produce results that can be trusted with confidence. And 3, tight integration with circuit design simulators in ADS and Cadence Virtuoso with the same and identical environment to access the FEM or Momentum EM solvers. So I thought the best way to show you RF Pro is to show 5 short demos on different applications with the most often encountered difficulties in setting up and performing EM circuit co-simulation, and show you how it is solved by the RF Pro EM simulation environment. So let's do it. So demo 1 is just a quick introduction just to illustrate to you how quickly and easily it is to set up EM simulation on a MMIC power amplifier. Okay, in this short demo, I would like to show you how to quickly set up and EM simulate your design with RF Pro. From the layout page, RF Pro is launched from the Tools menu. RF Pro automatically assembles the entire design, including its pins and components. Components with circuit models like FETs and SMT devices are usually represented with circuit models and do not require EM simulation. So by dragging the components down in the analysis section allows RF Pro to combine and co-simulate these circuit models with the EM simulation results of the layout. Similarly, by dragging all the design pins down in the analysis section, allow RF Pro to automatically create a port for each pin with a reference ground that is closest to the pin. Here in the Option tab, I set the simulation frequencies and I select the EM simulator. In this case, I chose the Momentum microwave engine. Next, I run the simulation. And once it's done, I can immediately view the results, such as S parameters of the EM simulation. I can also create test benches for ADS that automatically combine the EM co-simulation results of the circuit models with the EM simulation results on the layout. So in ADS, I open the top-level schematic page, and from there I can shift views and simulate both my original circuit level design with circuit models as shown here, or I can shift the view to the EM model from RF Pro and simulate it and see how my simulation results have changed. I can even keep the simulation results in the memory by turning the history on and be able to display both results on the same plot for better viewing of the change in the results from both views, circuit versus EM, as shown here. And this is all to it. Now, to put the next demo in context, remember earlier we discussed the industry trend of higher integration into smaller size? What you see here is an example of an RFPA switch module with multiple ICs, passives, wire bonds, solder bumps, and laminate substrate all integrated into a multi-technology RF module. If you are the designer, you will have to know if everything is going to work together before you sign off on building the hardware. So in demo 2, I want to show you how to conveniently assemble a multi-technology module using the drag and drop smart mount capability in ADS and simulate it using RF Pro 3D FEM simulator. Please pay attention to how quickly you can set up and run an EM circuit co-simulation without any manual reconnection errors. In this short demo, I demonstrate the use of smart mount technology in ADS to mount a mimic power amplifier onto a QFN package and bond wire it. Then I use RF Pro in ADS to quickly EM setup and EM simulate this whole multi-technology module. Let me show you how I do this. First, I start a new workspace as shown here. Then I import both design libraries into this new workspace, the Mimic Power Amplifier Design Library and the QFN Package Design Library. Next, I create a new layout, let's call it Module Assembly Layout, and I place all of the module components in it as shown here. Here you can see the whole module assembled together, the package, the Mimic PA, and the bond wires. How did I do this is very simple. First, I drag and insert the package onto the layout page. And then I drag and insert the Mimic power amplifier on top of the package. I insert the bond wires from the insert menu. It's really straightforward and simple, as shown here. Now, please notice in the P-cell customization of the Mimic PA, notice I select the artwork type to be Smart Mount with bottom mount configuration. This means when I insert the Mimic power amplifier onto the package, it will sit on the next menu. RF Pro automatically assembled the entire design, including its pins and components. Components with circuit models like FETs, like SMT components, are usually represented with circuit models and do not require EM simulation. So by dragging the components down into the analysis section allows up.
Sorry, there was some issue with my headphones, so I have to change it. So were there any comments or questions? Hello? Hello, can you hear me okay?
Yes, sir, we can hear you.
Yeah, so I was just... Yeah, go on.
No questions, sir. No questions as of.
Okay, so was the video playing okay, like the audio part especially?
Yes, sir, it's good. It was everything clear.
Okay, yeah. Drop me a chat. Actually, I'm facing some issue with my headphones, so I changed it to another one. So in case if I'm not able to respond, please drop a comment in the chat. Yeah.
Sure, sir. I'll do that.
RF Pro to combine and co-simulate these circuit models, namely the FETs here, with the EM simulation results of the entire physical structure. Similarly, by dragging all the design pins down in the analysis section allows RF Pro to automatically create a port for each pin with a reference ground that is closest to the pin. In the Option tab, I select the simulation frequencies and the type of EM simulation I want to use. Here I select the 3D FEM simulator for my entire 3D module structure. Next, I run the simulation, and once it's complete, I can immediately view the EM simulation S parameter results in RF Pro. I can also quickly create a test bench and an EM model subcircuit cell to be used in ADS for further analysis and data display in ADS. And here you can see in ADS, I can use that EM subcircuit model that came from RF Pro in a test bench and simulate the whole module and compare it with the Mimic PA simulation standalone. This way I can see the overall effect of the package and bond wires on the whole structure. So next, let's see what impact the industry trend towards millimeter wave frequency applications, such as 5G, automotive radars, and WiGig, has on packaging. You see, at millimeter wave frequencies, losses and parasitic of bond wires become excessive, and wafer-level packaging is required to integrate multi-technology RF modules. So in the next demo, I will show you how to assemble and route interconnects with interactive design rule check through a wafer level package, and then EM simulate selected nets without modifying the layout. In this demo, I would like to show you how you can extract any critical path or nets in your design and have RF Pro efficiently analyze them with EM circuit co-simulation and without any layout modification or cookie cutting. Let me show you how. The RF module and interconnect routing I'm using here consist of a silicon-based RF transceiver chip and a gallium arsenide filter, a multi-technology assembly on a fan-out wafer-level package. The transceiver IC is flipped and placed on top of a fan-in redistribution process layer, we call RDL, and connected with solder bolts and routed through a fan-out multi-layer wafer-level package. Now, one reason for the solder bolts connection is to reduce or eliminate the high loss and parasitic associated with traditional bond wires connections, especially in higher frequency application. But notice here, I used on the other IC chip, which is the gallium arsenide filter IC, it has bond wires connection. I used bond wires here just to illustrate to you the richness of mixed multi-technologies assembly and simulation in ADS. So here's a picture of the final assembly. Now let me demo this in ADS and RF Pro. Here's the workspace in ADS. First, let me open the transceiver IC pad ring layout, which is basically the footprint of the transceiver chip, and it has all the external connection pins. For example, here are the differential output pins of the PA in the transceiver. Please pay attention to this gap or the space between the pins on the right side of the pad ring. But this pad ring will be sitting on top of a redistribution layer, RDL. And notice the RDL has its gap on the left side, as shown here. But because the IC pad ring is configured to be mounted as flip chip, The gap on each one of them, when assembled together, will perfectly align. Here you can see in the P-cell customization of the IC pad ring, the layout is set to Smart Mount Flip Chip as shown here. So now, when I mount the IC onto the RDL, it should align properly because the IC has been flipped, as you see here. Next, from the main window, let me now open the fan-out wafer-level package schematic and layout views. At the right side panel of the layout page, the differences window is showing that this page is still missing the IC and RDL designs. So as you see here, I can easily drag them in and place them at the middle and on top of the wafer level package as shown here. The flight lines you see here will help guide me on where the interconnects must go in order to match with the schematic. So now I will use trace routing in order to perform the connections. Notice the routing also has automatic collision avoidance. This prevents lines on the same layer to collide or short and also help avoid breaking any DRC rules. To save time, let me now open the completed routed module. And here it is. All the pins have been connected and the module is now completely routed and ready for EM analysis with RF Pro. Now let me launch RF Pro from the Tools menu. In this demo, I want to perform a user-defined analysis on the interconnect routing between the output nodes of the power amplifier and the input nodes of the filter. To do that, I simply select the interconnect nets between the PA and the filter and move them down into the user-defined analysis section as shown here. Let me switch to Wireframe Visibility mode for better viewing. And here you can now see the two interconnects that I would like to analyze and check for their impedance match and insertion loss. The two nets names are highlighted on the interconnects coming from the PA output nodes. Next, in the Options tab, I define the simulation frequencies and I select the type of EM analysis. In my case, I chose the 3D Generation 2 FEM simulator. Next, I would go ahead and run the simulation. And I have already performed the simulation run for you, and I wanted to show you the summary page. You can see it took close to 2 minutes to complete the simulation on my laptop. Now let's look at the results. You can immediately view the S parameters results by clicking on it in the Results tab. Here I'm plotting the input and output return loss S11, S22, S33, and S44 of the 4 nodes of the 2 interconnects, so we can see how good the impedance match is. And it shows here that we have better than 15 dB return loss at 2 GHz. Next, I want to display the S21 and S43, which are the insertion loss of the interconnects. And here they are. So you can see the loss of these two lines are shown to be less than 0.4 dB at 2 GHz. This is important because we don't want these lines to have a higher loss than required, since any additional loss would take away expensive power from the PA output and reduce it. I hope you have enjoyed watching this demo. But please, I want you to remember that these user-defined analysis of critical nets or sections in your layout are done without having to modify the layout or cookie cut it. It is all done by selecting the nets and moving them down in the analysis section of RF Pro, as I have just shown. So in the next segment, I would like to show and demo circuit EM excitation and co-simulation in ADS. I will apply this technique on this 5G transmit module interfacing a 4x4 patch antenna. You see, 5G design brings lots of challenges, especially when combining and simulating high-frequency circuit design elements of multiple manufacturing technologies with different model abstractions, including physical EM models. Now, one very important design challenge in 5G is the dynamic impedance between the PA and the antenna. You see, as the scan angle changes, the energy in the array elements change, and that causes the impedance between the power amplifiers and the antenna dynamically change. As a result of this, a loss of transmit power happens, and under certain conditions, this reduction of power could be large enough to lose the signal and create what is called a blind spot. Here at the right side, I'm showing an excerpt from Dr. Neil Tucker's technical note, which graphically shows how the coupling between the array elements affect and change the impedance. Let me briefly illustrate this to you. For simplicity, let me first represent all 16 antenna ports as 50 ohm loads. You see there's no coupling between the patches, and all PAs are identical. Therefore, the PA output impedance and power are constant as the phase angle is swept from -60 to +60 degrees. Let me now use 16 random resistive loads between 40 and 62 ohms. Again, as you can see here, the impedance and output power are constant as we sweep the phase shift angle between -60 degrees to +60 degrees. Next, let me represent the 16 loads as complex loads extracted from the actual S parameters of the antenna at 28 gigahertz. But keep in mind, I'm still not including EM coupling from the patches, and the results still shows a non-varying impedance with the change in phase angle between -60 and +60 degrees. But now watch this. When I include the actual antenna EM simulation, including the coupling between all patches, look at the results. Look how the impedance at the output of the PA interfacing the antenna is dynamically changing with the change in the phase angle. And that is due to the coupling effect between the patches, which dynamically changes the impedance as we change the scan angle. As I said earlier, this dynamic impedance could result in reduction of output transmit power, and it could be significant and cause a blind spot, which is a very important issue in the design of 5G systems. To recap, the circuit EM excitation and co-simulation process in ADS allows you to combine and co-simulate this transmit chain with all its components, along with the antenna EM simulation, and deliver accurate simulation results of the whole system and all its components, including nonlinearities with harmonic balance simulator and also memory effects with circuit envelope simulation. So what you see here is the transceiver components on the schematic page, and they are all designed at the circuit level using Foundry Design Kit models, or they could be represented by their S parameter models or nonlinear X parameter models or EM models. And the output of such circuit simulation on the transmit chain drives and excites the physical antenna structure that's being simultaneously co-simulated with momentum planar EM solver or with a full 3D FEM solver in RF Pro. Now the output of all this at the far right comprises the complete circuit EM co-simulated results produced by capturing the excitation from the transmitter module and applying it directly to the antenna, all simulated simultaneously. Let me now demo this value.
Okay, so anyways, this is like a very good video which talks about various scenarios. And as we looked into some of these scenarios, talking about the S parameters from a power amplifier characterization, which was talking about the 8x8 MIMO or the patch antenna, and then some of the other packaging and all. So the whole idea is, as I mentioned earlier, like still we are seeing a lot of interesting work happening on the design and simulation side, which can be either focused towards the beamforming or maybe focused towards the MIMO antennas or on the network side. So let us quickly jump into another aspect on the network side, wherein we will be spending some time on the software side and then the component of machine learning, etc. So I'll just quickly jump over some of the slides as we have limited time in hand now. So very quickly, like from a 5G ecosystem or any wireless communication ecosystem perspective, like be it 4G, 5G, or 6G, from a test and measurement perspective, as we talked about the various components like UE or G node B or the network or the channel. Now, testing plays a very critical role, and starting off with UE. So the companies which are more on the UE side, they have to look into various parameters or metrics like battery life against temperature. Then they have to look into the quality of service, the throughput, and the latency. And for that, they may require some sort of emulator to test all these characteristics. Then many a times, if we are talking about microwave frequencies, we also have to do a lot of testing, which is more on the radiated testing side. So typically talking about these products, we have two modes. One is the conducted mode, one is the radiated mode. So wherein we either connect the cables directly for the testing, or basically we put these products into the chambers and then we are doing more of a radiated testing. On the base station side, which is totally opposite to the UE side. So here we are basically checking the reliability and the capacity of the base station, like how many UEs it will be able to support, then the radiated power and all. And then also the sort of protocol information, basically the header information or the packet information which is flowing via this base station. Channel plays a very critical role over here, because channel is something like, if you see the real world over here, like definitely in the ideal world, we would consider that there is no interference or there is no path loss between the transmitter and the receiver, which is UE and G node B in this case. But in the actual world, there are a lot of various conditions, like there may be interferences coming from buildings or maybe physical objects like your trees or any of those things. So definitely we have to emulate all these conditions, and while we are characterizing the channel. So channel testing plays a very critical role, which is basically testing the path between the UE and the G node B. Once we actually deploy all these things like the G node B or the UE in the real world, we also have to do a very robust testing on the coverage part, wherein we are actually talking about things like transmitted power, we are talking about the modulations, we are talking about the signal strength and the quality of service, which includes your throughput and the latency. One very interesting or typical use case, what we are observing typically while we are talking about surveillance as the use case in 5G is, like, you might be hearing a lot of work happening around drones. Now, drones, these can be like for either meant for commercial applications, or it can be meant for defense related sensitive applications also. So that is when, like, we really have to see what network it is deploying, what technologies it is deploying, and then scanning through all the frequencies, checking the signal strength, the modulation level, the power level, the EVM, etc. So that is when we talk about the fly testing also as one of the aspects within this particular application. And then also, as I mentioned, like 5G as a technology, it's not just limited to one particular band, frequency band. We are talking about various other bands also. Now, one application can be coexisting with applications related to radar and satellite. So we have to do a very robust testing on the coexistence or the interference testing side also, for which there are different hardware pieces, and then also software plays a very critical role over there. Okay, now coming to the actual software part, and that is when we are talking about the role of deep learning or artificial intelligence or automation or machine language or any of these terminologies you can say. And again, like I won't be talking about the various models, various regression schemes which are being deployed, but then what are the various challenges which can be solved by some of these things? Now, the earlier slides, they talked more on the overall system and which was covering more on the either on the design and simulation side or more on, I would say, the physical testing or the physical layer testing, which included interference testing or coexistence part or maybe emulation of either UE or G-node. The very key part of this overall system, if we talk about 5G or the future 6G, is the overall network infrastructure. Now, typically with 5G, like we are seeing various advancements or innovations on the networking side also. And you might be hearing some of these words like innovations like software-defined networking, for example, or virtualization, or disaggregation, or maybe something called as closed loop automation. Now, these are some of the things which are becoming a part of the overall network, which can translate from edge to cloud. Now, software-defined networking, just to give you a quick perspective, like earlier, we were having all the various components in place, and then the hardware was defining the entire network. So it was more of a static in nature, but now because the technology itself is evolving, it is playing in different bands. So this is more of a software defined networking now, where the role of software is very critical on how it slice and dice the entire network for different use cases. And that is when we have to put different algorithms in place to reroute the network and to best optimize it for the increased efficiency or for the usage. The second component is, which is very critical, is the virtualization. Virtualization means I'm actually bringing in all the virtual instance of a system to another point. So meaning like, let's say if we are talking about data centers, for example, or servers, for example, or any other component. Considering the overall complexity, we are basically bringing virtual instances of these different pieces to anywhere where it is required. The third technological innovation which is being talked about in this overall scenario is disaggregation. Now, disaggregation is like earlier in traditional days, the entire network, including the hardware and software, was defined by a single vendor or a single company. But then we are now rather disintegrating it into different pieces, meaning the operators or the vendors, they really have to open up the entire network from the usage perspective, and the software can be accessed or analyzed by any of these things. And then the final one, which is more on the closed loop automation. So closed loop automation is like, while I'm capturing the data with the help of these algorithms, I'm able to measure it, I'm able to do all the analysis, and I'm able to show the results or put it for further analysis. So there is a complete end-to-end automation approach which doesn't require any of the manual things. From a test perspective, now while we are talking about any of these technological innovations, there are definitely different challenges also associated with this. It can be either related to the virtual infrastructure, it can be related to your disaggregation, it can be related to your quality of service or the security part. So we will just quickly go through some of these aspects and then try to understand how exactly it is critical. So the very first thing which I mentioned earlier, that one of the key component is in 5G is the stringent latency requirement. Like we are really targeting a very low latency of 1 millisecond or less. Now, what does this mean is basically the operators who are adopting 5G, like they are really interested in moving it to flexible cloud radio access network architectures. So basically, we are talking about new architectures which can be either at the edge level or it can be like hundreds of kilometers away, more at the centralized servers levels. This overall 5G transport networking framework, which we are talking about over here, this is being defined as the X-Hall technology, and which is like a very key component for balancing the overall latency, throughput, and reliability. And if we talk about this, the new front haul technology. So basically over here, we are dividing the radio stack between two components. One is called as the distributed unit and the second one is called as the radio unit. And over here, we are actually talking about the data which can switch from one network to another network also. So again, there are different terminologies associated with this particular X-Hall framework, which is like worked upon to really meet these stringent latency conditions. The second one, which I mentioned earlier also, that over here, one of the use case or one of the features which is being looked upon into 5G is we are talking about multiple use cases. Now, multiple use cases, now these can operate either in low frequency bands or some can operate in high frequency bands or mid frequency bands, which means there is a requirement for dedicated end-to-end channels. Okay, now network slicing is a mechanism, again, which can be achieved by any of these algorithms or technologies like machine learning or various other techniques wherein we are slicing the network to really create a completely isolated end-to-end network. Okay, so for example, like let's say I'm using the same network for maybe a very less sensitive use case or the same band which is being required for a very mission critical use case. So I cannot really use the same network for both these conditions. So that is when we really have to look into slicing the network for these different use cases. And over here, we are talking about two different approaches which are being adopted under this network slicing. So one is called in the short form as SRT, and the other one is called as the flexible algorithm or the flex algo. These are two well-known approaches over here. Quickly, like if we look into SRT, so basically over here, we are talking more about the tunneling approach within this thing, wherein it will just, the nodes will restrict traffic to a particular condition. The second one, the flex algorithm, this doesn't require a controller or a tunneling approach, but we are talking more about the dynamic path provisioning over here. Okay, so the application or the use case can adapt to any of these approaches, but the whole idea is how to really slice and dice the network for the best usage. The other very key component, while we are talking about tons of data which is being generated and analyzed, so security plays a very critical role over here. Now, security is like any of the data which is being transferred between the transmitter and the receiver. So it's all encrypted. So meaning we don't have a direct access into that data, but then someone who is really managing all these data, be it at the front haul side, the mid haul or the back haul side. So we really need to decrypt all this data. And then also while we are decrypting this data in the transmission, we need to look into the entire layer for a security perspective. So again, there are different approaches over here. So which can be, I would say there are two broader approaches. So one is the max security, the other one is the IP security over here. And basis the application or the use case, any of these terminologies can be adopted in various algorithms. One very key component, if we look into the overall ecosystem over here, is we are talking about a very wide portfolio or a wide ecosystem, and we are talking about huge chunks of data. So we cannot just rely at the cloud server side or the cloud computing side to manage the entire data. Okay, because here, if you see, like in real world, each day wherein we are talking about billions and billions of devices which are being increasing every day. So we are talking about exabytes of data which are being generated. Now, how these algorithms or machine languages can really capture this data first and foremost, analyze the data, and then make it meaningful. So the way it is being done is we are talking about computation at different stages, meaning at the edge itself, which is being called as the edge computing. Then we are talking about some computation at the transmission layer. And then the final one is more on the cloud computing side. But in order to handle all these chunks of data, we really need a very robust channels. Also, we need robust servers, data centers also to capture all this data. And then the algorithms in place should be able to decrypt the data and then do all the analysis which is being required over here. How much time I have left for me? So I can say it is 5 now.
Sir, actually session is till 5.
Okay. Okay, no worries. So maybe I'll just quickly wrap it up in another 5 minutes if that is okay.
Okay, sir.
Yeah, thank you. Okay, so yeah, so we talked about the overall 5G architecture and the importance of edge computing, cloud computing and all, but definitely as I was talking about various other things like cloud servers and the backplane, which is more on the way it is being, data is being transmitted. And also over here, we are talking about various other technologies like Wi-Fi 6, for example, or maybe we are talking about 400 gigabit Ethernet or 800 gigabit Ethernet, which will be required to transmit this huge chunks of data. And then also all the various algorithms which are being deployed at various stages to first and foremost analyze the data, and then basis the usage, it can be repurposed or leveraged, considering all the security aspects also. So these are some of the things I would say which are being worked upon in academia at the moment. And these are certain topics which I think any of you, like if you are moving towards industry, or maybe if you are willing to look into some particular detailed projects. So these are some of the areas which you can really look into. And we have very limited time in hand. So I would recommend that either you can look into keysight.com for more details, more research ideas around these topics, or I will just type in my email ID also in the chat window, and you can reach out to me for any of the additional details from my side. So maybe next 2-3 minutes I'll just spend for any Q&A, and otherwise we will try to conclude this in the respective time. For Siddiqui@keysight.com. One interesting portion which I couldn't cover today, and sorry for that. So that was basically focused around V2X, like how 5G as a technology is being deployed for automotive industry. So in case if any of you are willing to look into CV2X, reach out to me and I'll be able to share more details around that. So let me quickly go through any of the questions if I can handle now. Okay, so there was one question about any of the tools and software that can be used in all aspects of 5G related to Keysight. So as I mentioned now, there are various tools and there are various hardware and software pieces which are being deployed at various stages, be it either on the UV side or on the network side or design and simulation side. So I would recommend that please visit keysight.com/find/5G and you will be able to look into all the details. For this. The second question was on maximum frequency by spectrum analyzer. Okay, so we now have a spectrum analyzer which can really go up to 110 gigahertz. And there are different platforms like maybe up to 3 gigahertz, up to 6 gigahertz, up to 9 gigahertz, 13 gigahertz. All those details are available on the website. Okay, so I think there are no more questions, or if there are any questions, please let me know. Otherwise, I'm done from my side. Any questions, any comments from anyone? Otherwise, we will conclude. If no questions, thank you so much for giving me this opportunity, and thanks again for attending to this particular session. Thank you.
Yes, sir. Thank you very much. That was an excellent and informative session. And it was very, we can gain more knowledge on the more algorithms to implement in wireless communication through machine learning. And thank you so much, sir.
Yeah, thank you again. Yeah, thanks.